This video is for pilots that have a private pilot rating already, or maybe they're getting close to getting their private pilot rating, and perhaps a pilot that has already everything through MEI and multi-engine ATP. This is a course for the Airbus A320 Neo, and a lot of this pertains to the pre-Neo aircraft as well, or the legacy A320s. So what we're going to cover today is the power levers and the pitch trim auto trim system. So generally speaking, without getting into all the details right away, the power levers are controlled manually. That's the only way they can be controlled. The auto thrust system does not move the power levers while it is adjusting the N1 when you have auto throttles engaged or auto thrust. The pitch trim system, unlike any aircraft I've flown before, is completely auto. And basically the pitch of the aircraft will stay where it is without you having to manipulate a pitch trim wheel, electrically or manually. There is a pitch trim wheel. We'll talk about that in another session, but today just want you to know you do not need to use the pitch trim. The nose will stay where you leave it in most cases. There are some cases that we'll discuss when the pitch trim will change without you moving it. But for today, the pitch trim will stay where you move it, or where you've already moved it. And just to review, the auto throttles, or excuse me, the power levers will not be moved by the auto thrust system. So here are the power levers in the Airbus A320 Neo. As you move them, they click in and out of these detents. The first one here is FLX MCT, which stands for flex power and max continuous thrust, and then CL for climb. And if it's in this range, the auto thrust will, if it's engaged, as long as the power levers are in this range, the auto thrust will control N1 for you. N1 is how we measure the power in this aircraft. That's the speed of the fan. So this is the lowest thrust setting. And of course back here you have reversed thrust. You'd have to be in the actual aircraft to feel how to get over into the detent into the reverse thrust. As you can see, there is a range and there is full reverse thrust. We will put this in the description, this address. And as you can see, there are many subjects here that it discusses. For example, the flaps, the cockpit door seal panel, ATC TCAS panel. We'll start with pitch trim wheel. The A320 has a feature called auto trim, which makes it unnecessary to hold the side stick or use the trim wheel for holding the current pitch. The auto trim is using a load factor demand mode, which means in level flight the system maintains 1G and no input is needed from the pilots to correct for speed, turns, or configuration. In other words, if you put flaps in, the pitch will remain the same. The system is always active, even when the autopilot is off. In normal law, the laws which we'll discuss later and we'll give you some resources for, which means under normal circumstances with a fully functional aircraft. Nevertheless, the pitch trim wheels in the cockpit provide mechanical control of the trimmable horizontal stabilizer and have priority over electrical control. The autopilot is disconnected when a pilot uses the trim wheel during flight. Note, pilot's use of the pitch trim wheel does not disconnect the ELACs to make sure that the computers maintain synchronized with the manual selected position. So, of course, this is what we're using instead of a control column like a steering wheel. And of course, on the right side, you have one over here. Description for the thrust lever panel. The A320 has so-called FADEC, which stand for Full Authority Digital Engine Control, and is responsible to ensure the engine is performing at maximum efficiency for a given condition. As one FADEC dedicated to each engine controls the engine's operation, the pilots, or the FMGS, can set the thrust. The pilot uses the thrust levers when in manual mode, and the FMGS sets the thrust in auto mode, A/THR, aka takeoff thrust. And again, the power levers will not move when the FMGS sets the thrust in automatic mode, or auto thrust. The levers in the A320 can only be moved manually and are not moved by an auto throttle system as it does in Boeing aircraft. The FADEC controls and limits thrust not to exceed the limit set via the thrust lever position in both manual and automatic modes. The FADEC receives the current thrust lever position and computes the thrust rating limit and the N1 for that thrust lever angle, TLA. If the thrust lever is between two detents, the FADEC will select the rating limit of the higher detent. In other words, if it's between CL, which is climb, and MCT, which is max continuous thrust, in that scenario, it will default to MCT. So if the power levers are set right here, it'll go to MCT power setting. Manual thrust control. When the auto thrust mode is not armed or not active, levers in wrong position, the engines are in normal mode. The thrust lever position controls thrust for the corresponding engine in this case. By moving the thrust lever, the pilot can set the thrust level, which corresponds to an N1 between the idle and toga positions. So this is idle, and this is the toga position. Takeoff, GA, go around, toga. FLX MCT detent. We just saw that. On the ground, the engine will produce the maximum continuous thrust, MCT, if the crew did not set a valid flex takeoff temperature. It needs to be higher than the current total air temperature to have an effect. You would do that in the MCDU, which is the button face of the FMS, if you will. But that's not actually the FMS, that's an MCDU. It's just an input panel. After takeoff with a flex thrust, the pilot can, by moving the thrust lever to toga or CL for climb, choose MCT thrust. It is not possible to go back to flex thrust. Note, setting the thrust lever out of FLX MCT detent without reaching toga or CL, we'll just call it climb from now on, detent has no effect. Max takeoff thrust can always be achieved by pushing the thrust lever all the way forward. Automatic thrust control. In auto thrust mode, the FMGC computes the thrust. Thrust is limited by the thrust lever position, except when in alpha floor mode, which we'll discuss in the future. Auto thrust instinctive disconnect push button. Each thrust lever has a so-called auto thrust instinctive disconnect push button in red. Pressing it disconnects the auto throttle. This button here. If the flight crew pushes and holds one instinctive disconnect push button for more than 15 seconds, the auto throttle system is disconnected for the remainder of the flight. All auto thrust functions include alpha floor. Start over again. All auto thrust functions, including alpha floor, are lost, and they can be recovered only at the next FMGC power-up. That concludes this session on the Airbus A320neo. Please subscribe, like, share, and comment, and click on the notification bell. And in the comments, let us know what kind of video you would like to see in the future. Thank you for watching.